Well, thanks, Terry, for the introduction. My name's Juliette, and if you were sitting here before I arrived, I was with said new son, putting him to a nap elsewhere in the car. Just kidding. Don't report me.
Exactly. Just a crack.
So as Terry mentioned, I'm going to be discussing sort of a whole life carbon approach to the envelope. It's always funny being in kind of conventions. I'm an architect in training. I'm an intern architect is what we call ourselves. So I'm gaining my hours. So I can't technically say I'm licensed yet, but I do work alongside a lot of other architects in the design of buildings. And so while I don't always interface with all of you folks, I think it's always great to be here and part of the conversation. And I really hope that the things I talk about today are, there to spark that conversation. And I'm going to start.
Hang on one sec. Try again. There we go.
Oh, okay. So we're going to go through some context, ideas about the climate crisis, that sort of thing. I'll speak to this one specific study on the envelope that my company has done, some key takeaways, next steps, and then we'll open for a Q&A. Also to note, if there are any francophones in the crowd, there are some French printed out copies of this presentation if you'd like to grab one of those. So with regards to context, here's an image of Sir Norman Foster and Buckminster Fuller. We're following a tour of the Sainsbury Centre. Bucky asks, "But how much does your building weigh, Mr. Foster?" And 2 weeks later, Foster responds with a detailed letter writing, "Dear Bucky, you asked about the weight and volume of the building, which are as follows." And he continues to list out each building element category with a weight indicated, including mechanical, structural, interior systems, and finishes. And the total building weight is stated at just over 5.7 million kilograms. But that's not really a true representation of the total weight of generated by this building. Mr. Foster's math is incomplete, because for every ton of aluminum in these custom aluminum facade panels shown on the left, 1 to 2 tons of red mud or mining byproducts are left in countries like Guinea, Australia, Brazil, and China, who export the world's aluminum. So you can't really understand the Sainsbury Centre without also understanding the Norsk hydro tailings ponds in Brazil. These are the same building, okay? These are the same project. And to sort of bring this example a little more local, this is my business, little lag. Some of these images are quite heavy. This is my business partner's Kelly Doran's cottage on Havelock Lake in Ontario. Okay, it's designed to be off-grid. It's got a super tight envelope. It hit all these sustainability goals and was written up in various architectural magazines. And a few years ago, my business partner sort of discovered the concept of embodied carbon and basically reassessed this so-called very sustainable, highly airtight project from that perspective. Okay. And what he began to understand was that this project had, was composed of a bunch of materials that were brought in from various places around the world. And he started to, attribute little flags to where these things were coming from. Okay. Windows from the US via Canada. Okay. So there's some back and forth happening there. And just on that, this is sort of the mapping out of where the elements of the window system, which I give it to you all, much more about Windows than I do, and I'm here to learn from you just as much as I hope you learn from me today. Okay, but with the Windows in his project, he has some friends that work in this industry, and they sort of helped him to understand where the glass was coming from, where the frame was coming from, with any other treatments were happening, where that was going. And so you can start to understand this really complex network, and that's just for one window system, right? Not the whole building when we start to think about a more global and complex supply chain. And, considering how to account for all of these impacts becomes increasingly important as we start to consider the emission scenarios that we're facing, right? A heating world, and along with it, all of the really disastrous consequences of said world. And so various organizations, folks like Architecture 2030, if anyone is familiar with them, have started to establish reduction goals. So Architecture 2030 has set a 50% global reduction in annual global CO2 emissions by 2030 in a way to limit warming to 1.5 degrees. And so how do we go about having the emissions? And importantly, what are we talking about? Which emissions are we talking about? So you may come across this kind of pie chart before, right? Where I work is in that 11% band, building construction, renovation, and maintenance. Of course, building operations is important, and we think about envelope design, what windows we're using, that sort of thing in that 28%. And so in total, about 40% of annual global emissions are attributed to buildings, okay? Buildings, and technically, if you want to get more technical, infrastructure as well. So it's a bit harder to separate the building construction, renovation, and maintenance emissions, which is often what we refer to as embodied carbon. We can't really easily separate building and infrastructure into a percentage, but we're gaining more and more data to do so. So on the one side, we've got these 28% of building operations. This is where the majority of the focus on regulating emissions has been, okay? We use energy use intensity, EUI, as the metric. In this case, in the study that I'm going to present, we've converted that to a global warming potential so that the numbers from the operational side can speak to the numbers on the embodied side. But in Ontario, this accounts for roughly 20 to 25% of a building's total emissions, okay? When we move on to the embodied side, the emissions that are from the materials, from raw extraction, transport, processing, replacement, renovation, repair throughout the life cycle of the building, and then all the way down to the end of life scenarios, this is what we're talking about. And in Ontario, this contributes a much higher proportion of a building's footprint, roughly 75 to 80% of total footprint, okay? And there's a few reasons. The grid is one such reason. These are also figures that, are present day. So as the grid decarbonizes, we might also to see these shift where embodied carbon holds a larger proportion of total footprint. And so, like I said, to date, we've really focused on the operational carbon side of the conversation. So things like passive house, energy ratings, that sort of thing. But when we take a wider lens or wider view to it, we start to understand the life cycle as a whole, right? So we were just in that B6 box down there, operational carbon. When we add the A1 to 3, A4 to 5, the rest of the B phases, the B modules, and then that C1 to C4 end of life stages, then we can start to talk about whole life carbon, right? And if we exclude the B6 phase and we maintain those other modules, that's what we refer to as embodied carbon, okay? And so what my company and what I'm personally interested in is seeing what the kind of synergies and trade-offs are between the two. And it's important to note to understand the relative importance of operational and embodied in different contexts, okay? So on this slide, we have two high performance buildings, one set in Calgary and one set in Toronto. I will call out before anyone calls it out for me that the y-axis is not to the same scale, okay? So you'd have to understand this one here is at 100,000 and the other one is at 25,000. So if they were scaled to the same, the bars on the right-hand side would be much smaller. But for visibility, we've done it this way. And so what we're seeing is that in 2030, in Calgary, a high-performance building, the embodied carbon emissions relative to the total emissions is roughly 50% of total emissions. But when we flip to Toronto, that has a different grid distribution, okay, sourcing materials from perhaps different places, we're seeing that embodied carbon contributes 94% of total footprint. So that's sort of where, my business partner, he's a bit older than I am, and he kind of, alarm bells started ringing. He did his assessment of his cottage. He came and taught at U of T. We met, and sort of University of Toronto, U of T. And then we've gone into business together and to really interrogate this. This was kind of a light bulb moment for him. And with the envelope specifically, what is important, can you see? Should I move this? So is that better? Okay, sorry, I should have asked earlier.
My brain is automatic.
I'll just do this anyway.
Okay.
There we go. Okay, so the envelope is important because it contributes roughly 30% of all the building component categories in a building. 30% of the emissions are from the envelope, okay? And, compared to structure, which usually contributes a lot because we use a lot of concrete and steel and rebar, and then your interiors, which is a smaller proportion. And seemingly not populating, but if you can imagine a big pyramid here with a bunch of materials on it, we'll send around the slides after.
You're doing that already, right?
You fill the hole.
Already doing it, yeah.
So at the top of the pyramid, there would be materials like aluminum, okay? We get into some petrochemical-based materials like XPS, that sort of thing, insulation. And then towards the bottom, we've got things like hemp and straw and wood, okay, bio-based materials. And the idea is that at the top of the pyramid, these are the materials with higher carbon footprints, the things we want to use more sparingly in a building. And as we move down the pyramid to the bottom, we've got the bio-based, the regenerative, the things that store carbon and that we would want to use more plentifully. So hopefully you can imagine that. And so it's important that we talk about the envelope because not only does it, represent a significant proportion of emissions in a building, but also we're using these high carbon materials. So I'm going to get into the study for the next few slides. No, metals have the highest carbon intensity. Yeah. Concrete's a couple bands down, but we'll make sure it's in the version that we can send out. But it's a Danish, actually, the pyramid is a very cool tool. It's a Danish school and company working together, and it's all interactive. So you can sort of, as you input quantities of materials, it reshuffles itself to tell you what the highest carbon footprint material is. So this was our kind of research question. What are the trade-offs and synergies between operational and embodied carbon within the context of building envelopes? And we went into this obviously a little biased to the embodied carbon side, okay, but really open to learning what those trade-offs might be. I worked with Kelly Doran, my business partner, and Ted Kessick, if you know him. He's a professor of building science at the University of Toronto. And we isolated 4 wall types. 2 on the left were residential, 2 on the right, commercial/institutional. All of them we assumed were located in Ontario. They had varying buildup, like assemblies. So one is a brick on timber studs with a PVC framed double glazed unit window. Then we had an aluminum framed double glazed unit window wall, which was a high-rise residential building. We have the wall 3, a timber clad on glulam beams, columns, and aluminum frame triple glaze unit. And then finally, our 4th wall, which was a terracotta cladding on CLT with PVC frame triple glazed unit. And so we're seeing different window to wall ratios. We're seeing different overall thicknesses. We're seeing different thermal performances across these 4 walls. For some of the operational energy assumptions, okay, to make it there are definitely limitations. I have a slide on that so we can discuss that at length when we get to the Q&A. But Ted has a methodology for how we want to quantify the operational emissions that help to remove some of the externalities from the analysis. So we assumed 100% electrical efficiency for heating and cooling demands, heating and cooling degree days that were obtained from the Climate Atlas of Canada to account for future climate model forecasts. And then to convert the energy use intensity to global warming potential, or GWP, we used a TAF, which is a Toronto Atmospheric Fund, a TAF published marginal emissions factor of 134. And then finally, we assumed a 60-year building service life. When it came to quantifying the materials, and developing a bill of quantities, we modeled each wall type in detail, and then we normalized these to represent just 1 square meter of area while maintaining the glazing proportion. So we wanted to keep the window to wall ratio. We just wanted to understand the walls at 1 square meter so we could more easily compare across them. And then we got into the fun stuff, which is the exercise of mapping EPDs, or environmental product declarations, the documents that contain all of the information about the emissions of a product or material, something that I don't do in my day-to-day. Someone way more qualified does that, and I just use that information and map it onto the quantities that I'm working with to understand emissions and breakdown of that footprint. And so we used a tool called One-Click LCA. Has anyone heard of One-Click LCA? Familiar? EC3 is another one. There's a variety of them that exist. And we selected EPDs that were most appropriate for the materials in the assemblies we were working with. So I'm just going to run through very quickly the 4 walls with their embodied carbon results. So I apologize, it's in little at the bottom of the screen, but I'll read these out to you. For A to C emissions, okay, so from that raw manufacturing all the way to end of life, excluding operational, our brick wall was at 84 kilograms of carbon equivalent per square meter. Our aluminum double glazed unit window wall was at 140. The timber clad on mass timber with aluminum frame triple glazed unit was at 147, very close to our second wall. And then the 4th wall, the terracotta clad, was at 95. Okay, so we're seeing there that the 1st and 4th walls were performing quite similarly, and the 2nd and the 3rd walls were performing quite similarly. And if we break down the embodied carbon by material across the 4 wall types, we can see the story of what's driving emissions. Okay, in this case, again, small letters, so I'm going to point some things out. That big gray bar in the middle is aluminum window wall. That's pretty much, 100% of what the building was this system. And then that kind of peach color we're seeing is PVC window system. Okay, so the EPDs that we used, the environmental product declarations that we used, were ones that had the window and the frame together. You could also separate those out and search for those separately. But when you use the system, if you have it available in something like One-Click LCA, you may as well use the whole system. And so what we're seeing here is that those are what the largest proportion of emissions are coming from. And so looking at embodied carbon alone, we can see, like I said before, that the masonry projects, so the brick and the terracotta, with the PVC windows, perform relatively similarly. And then we look at the 2 with the aluminum frame windows, and they're performing more similarly. And when we isolate the 2 walls in the middle, this is where we start to see the difference in operational, right? The difference in operational, this multiplier at the bottom of the slide is telling you how many times more the operational is contributing relative to the embodied. And so where we have, an envelope with a significant amount of insulation and other layers to it, the difference between the operational and embodied is much higher than where we have a double between the 2. So what we're saying here is that the operational emissions of wall 3 are so small that the embodied is 15 times that amount. Okay, so we start to kind of interrogate, okay, well, what's going on here and how can we learn from this to inform building envelope design? One last thing, actually, just to note on this slide, if you've noticed at the bottom here, we've got biogenic carbon. Okay, some of them, the 1st, 3rd, and 4th all have a biogenic component. That's just the amount of carbon that's sequestered by bio-based materials. So your woods, your hemp, your straw, that sort of thing. The best practice is to report it as a separate value and not account for it in your totals. But we did want it to be represented there because it can contribute significantly. And so in this conversation, is there opportunity for a return to more wood-framed window systems, for example? And then when we isolate the operational performance, this just doesn't reveal the whole carbon story. The high embodied carbon of wall 3, for example, which was performing very similarly to wall 2 on the embodied side, like we just saw in the previous couple slides, is not being shown here. Here we're seeing that wall 2 would be the kind of outlier from the perspective of operational performance. And when we sum up both operational and embodied, we get, we're able to make more meaningful comparisons across these wall types, right? The previous slide, when we focused just on operational, doesn't capture the high embodied carbon of wall 3. So when we start to put those 2 elements together, we can start to understand the bigger picture of what's going on. And on this slide, where we're seeing these little jogs up, these represent things like repair and replacement cycles that need to happen in the envelope. And so just for some key insights here, the initial sample of these 4 wall types show that the embodied carbon impacts can far outweigh the operational ones. And so there's an urgent need to understand these and then to begin to assess them. And then ultimately, this might require a fundamental shift in how we're thinking about designing the building envelope. It might require a shift in the materials with which we're building, in the window to wall ratios that we're building to. And so this kind of understanding may start to inform more research, more design, and more policy. And like I said, to kick us off here, there are a few challenges and limitations with the data that we are very well aware of. And, we're hoping that this study kind of kickstarts future studies that will be able to address some of these limitations in. So first, there were, just a lack of available data. We're working with an industry that's relatively new in North America. Environmental product declarations are getting published every day. So every time I go back into the tool, I might see a new one that is more accurate to the window system or the brick or the insulation that I'm working with in the wall. So there's always a bit of assumptions happening, right? So that's one piece. The second point is that we had to ignore some material components. It's sort of related to the first point. Things like thermal brackets in the wall. Currently, there's no EPD that I can find to represent that. So we decided the best course of action was just to ignore it and make note of the fact that we ignored it. So in a future study, maybe there is an EPD, we include that, and the numbers become a little more accurate. There's also some inaccuracies by assuming the service lives in the EPDs are actually what is used in real life. An EPD for a window system might say it's good for 40 years, and in reality, we know it's good for 30 years. There's an example. We can discuss that more at the end. Totally made up that one. But how those numbers start to influence the total emissions is also something that's important. A range of other factors could have been considered, and should be in future studies. We focused on GWP, global warming potential, but there's a host of other environmental impact categories that are important to consider. Acidification, ozone depletion. If you've worked on a building that's ever gone for LEED, they actually need to optimize across a variety of these environmental impact categories, not just carbon emissions. So we isolated that, but really we could expand it to do a wider study. And finally, when we get to the operational assumptions, we didn't consider that the embodied carbon investments for envelope systems that it may aid in solar shading, et cetera, would help to, change the numbers on the operational side of things. We also would require a deeper understanding of the mechanical trade-offs. If we move to a double glazed system, what does that mean for the mechanical loads? That was excluded from this study. And that is something that is crucial to understand before we start pushing for, using double glaze versus triple glaze. This is merely stating that there's a whole other piece to the equation of emissions that we do need to understand. We also did not account for decarbonization of the grid. Okay, so we've now started to model things out where we're seeing that happen, and that again would paint a slightly different picture for these numbers. And so for some key takeaways, what we believe coming out of this study envelopes should focus on is ones that incorporate reclaimed and recycled products that still achieve a certified performance. Envelopes that have an appropriate window to wall ratio that consider the climate that you're in. Envelopes that use timber or bio-based elements and other carbon storing materials. Ones that enhance passive heating and cooling, okay, thinking about where we're putting windows for daylighting, for views, for the opaque wall, what is that buildup? Can we enhance solar heat gain? And envelopes that balance a simplified assembly with acceptable performance. So can we really move towards less material, fewer materials in the assembly, right? Or materials that serve a double function. I worked on a project recently in the UK, a hospital, and we proposed hempcrete blocks for the wall, and it serves, the infill, it is the insulation, it has breathable properties, it helps to lower the mechanical loads. It's pretty neat material. It's been approved. We'll see if it gets built. We'll let you know. And ultimately, it's about kind of optimizing between embodied carbon, performance or operational carbon, and durability, thinking about how long the things that we're building with last. So for some next steps, this is, in all honesty, a bit of a plug for what we do, but just so you're kind of aware of the work that's being done on the architecture side of things. My company with my business partners, Ryan and Kelly, was founded to help understand this question of how we're going to have the emissions of the built environment. So we kind of addressed, where we're looking to have these emissions. How do we get there? So we do LCA assessment. We try to understand the differences between operational and embodied carbon. So what we've begun to do is on other projects, we're kind of creating this heat map of the different envelope systems. So this is just embodied, not the operational. That's analysis is being done now. But just understanding, okay, where are the emissions happening? Okay, so right now our kind of red ones are in our window wall and our unitized curtain wall. So that to us just is like, cool, what can we do about that? What is the window to wall ratio in those areas? What's the height that we're building to, et cetera? In this study, we were looking at an office building in Vancouver. Actually, sorry, in Victoria, BC. Got to get my BC geography correct for this guy over here. I know. And we looked at, this building was specified with triple and quadruple glaze systems around the building, which I didn't know existed until I did this study. And, we started to understand, started to question with the BC grid being relatively green, relatively clean. What would it look like if we just switched to double glaze from the perspective of embodied carbon, but also from the perspective of cost, okay? And so again, you might start to question the emissions factors we've used. If we were to redo this study, we probably wouldn't use what we see there as MEF, the marginal emissions factor, and we'd use the average emissions factor. There are ways of poking holes in this data, 100%, but it started to, we spoke with the architects, we met with them, and they internally started to look at whether they could change the specification for this building. In this case, we were looking at what traditionally happens at the end of life of a facade, okay, where we're seeing the red in this chart at the bottom, the red on the facade itself, are things that typically end up in landfill or are disposed of. And we were curious, how do we start to bring more green or at least orange into this, where we're seeing more recycling, reuse, et cetera. So how do we move from demolition as being the end of life to something like circularity, circular systems, designed for disassembly, unitized disassembly? And so we're designing from the start systems that are more easily disassembled at the end of life, where the component parts could be reused or recycled. Or we're taking apart the whole unit and reusing that. And then we're working with a lot of policymakers, other industry leaders to help understand these issues more deeply, and then help that kind of in turn inform policy. Currently, we're working with Toronto's urban design and planning teams on an urban design guidelines study, looking at low-rise, high-rise, and mid-rise buildings. In this case, we were looking at buildings with step backs and saying, are there unintended consequences from some of the design guidelines that exist in those documents? So we studied the existing massing at one step back and no step back. And from the envelope's perspective, fewer shifts and turns also simplifies the envelope. We might prevent some of those issues where we're meeting corners and joining things. And start to understand the per square meter carbon performance of these different sections. So the parking below grade, that retail in the middle, okay, often with a lot of glazing built to 4.5 meters, and then the residential above grade. Also in that orange band, things like transfer beams, if we're talking about structure, right? Because we have a different structural grid from the retail to the residential and the parking to the retail. So all of these elements are captured in this kind of study, but we can start to zoom in and say, okay, well, that number in that orange band is the highest. What does that mean? And what are the opportunities for lowering that number? And, what kinds of metrics are we putting out there? We, on the previous slide, are presenting it as a per square meter or a per floor area understanding of carbon, but how might we understand it as a carbon per density metric for something like residential, right? In a hospital like the one I designed, we started doing per bed, because for us, it was interesting to know how much carbon are we building with per person we can keep in the hospital. And then finally, we've started getting into pre-deconstruction audits, material reuse assessments, and really focusing on this like rightmost part of this graph where we're shifting towards more regenerative design, using more bio-based material. And in this study for the Mass Timber Institute that's affiliated with the University of Toronto, we were comparing between a very typical office building. This is just structure, so we ignored the envelope on this one. That'll be the next step of the study. But we looked at concrete, steel, timber, and then a hybrid timber. And in Toronto, we'll be repeating the study in Vancouver and a variety of other cities. For Toronto alone, we're seeing that the mass timber and the hybrid mass timber are more favorable in terms of their per square meter carbon emissions to design these kinds of systems than to continue designing with just concrete or just steel building systems. And so to conclude, before we open to a Q&A, I just want to highlight the kind of interconnectedness of the construction industry. I don't know how many, is anyone an architect here? No, engineer? Okay, nice, cool. We also get pinky rings, just so you know. Yeah. But really, you know, there's like the material manufacturing, the product manufacturing right there. I'm in that architectural design. We've got the demolition industry, the reuse industry, the recycling industry, the waste industry. I'm missing government and policy on this slide, but really, I just want to highlight this kind of interconnected network and highlight that we as designers can work with product manufacturers to push for research, policy, and ultimately a design that's both more regenerative, bio-based materials, circularity, reuse, and resilient for, you know, a better future for us all. And with all of that said, we'll open for a Q&A. Please feel free to reach out if you don't get your question addressed today, but I might sit for this portion so it feels like it's more of a conversation. That's okay with everyone. But thank you.
Anybody? Can you come up to the mic if you've got a question?
I'm just wondering what assumptions they use to determine the embodied carbon of glass.
Ooh, that's a loaded question, and one that I unfortunately don't have the best answer for you. I mean, in the study we did,
I'll do it.
We chose EPDs in the tool we use, which is called One-Click LCA, based on the window systems that had been specified in the buildings themselves. Currently, there's a limitation in that not all manufacturers have EPDs out there. So a lot like Alu, Quebec. I know there's a lot of Quebecois people here. I don't know if people are from Alu, Quebec, representing Alu, Quebec today. That's one that comes up a lot. So sometimes we have to use an EPD that's not actually the exact window system that was used in the building. And that's one of the challenges. So we have to look at what the EPD is representing in terms of dimensions and what it catches in terms of material quantities and assess whether we think it's close enough to what the building used. And so there's a little bit of that. In other cases, the exact window that was used in the building has an EPD. We use that, done and dusted, and it's more accurate.
So, you know, I'm just thinking we don't do any float glass in Canada. It's always because there's environmental concerns with the amount of energy that it uses, and we don't want that on our scorecard. But we bring it in from places like China where they burn coal to produce it. You know, so I'm thinking, what if we could produce glass in Canada somewhere where the grid is very decarbonized? Wouldn't that be a great advantage when we start analyzing buildings like this?
It would be a great advantage also just from the perspective of transport, right? You're then, it's more local, you're supporting local economies. I mean, yes, absolutely. I think that would be.
I think somebody needs to start telling governments this.
Well, as my last few slides said, we work with policymakers. So, you know, there's like an opportunity to get together and push this on the policy front for sure. Hi.
Hi. You talked a lot about EPDs and getting accurate EPDs. How sensitive is the analysis to the quality of the data in the EPDs?
I mean, I would say that the quality of the data, all the EPDs we used are third-party verified. It's, you know, you could go on the internet and Google an EPD and use that. It might, that's from a direct, you know, manufacturer website. That's not the best practice. All of the ones that we use have been verified by a third party, not even the tool that we use. They have another person that verifies. So, and the EPD itself is typically an external body goes into a manufacturing plant and does the whole assessment, is kind of technically what it should be. So there's various levels of verification involved to ensure that the numbers we're working with are somewhat accurate. Where there starts to be some inaccuracies is more so in like choosing, like what the prior question, not having the exact EPD for the system you're using.
Okay.
Then you start to see some issues with the data.
I was wondering, regarding like the study you did, what were the assumptions made in the EPDs about the end of life of the window systems? Were they assumed to be recycled or just thrown to the landfill, or was that excluded from your study?
No, so the end of life was included. And it was, windows were one component of looking at also opaque walls. For the most part, we, maintained the default assumed scenarios that the EPDs had set out. So in this tool we use, you could go in and say, actually, this was disassembled, or actually we used a reclaimed brick or whatever, and that'll affect the numbers, of course. But in this scenario, I'm fairly certain metals would have been recycled, melted down, recast to something, but the glass was disposed of.
I have to choose off my list of questions here. On the LCA calculators that are online, I mean, what's going to happen is people in this room are going to be asked to put up LCAs to satisfy government regulations, right? That's where it's going eventually. Obviously, that system needs to be formalized or standardized somehow. It can't be a matter of going on and picking your favorite calculator off the internet and generating your numbers that way. And I understand there's third-party verification, right? So there's going to have to be recognized bodies. I don't know if it's ASTM or whoever, but there need to be standards, right, Terry? Like the association literally needs to get to work with the governments trying to figure out what's going to be recognized for generating these numbers, right? Because otherwise they'll just be fight. So what do you think the path forward is on that, Julie?
It's a loaded question.
I love loaded questions. That's my whole life.
As do I. I think so. There's kind of two levels of LCA work that's being done, right? There's the product manufacturer side, where whether it's done in-house or, a window manufacturer hires a body to come in, assess the emissions through the life cycle, and produce a document that is then used. That's the creation of an environmental product declaration. And that for, whatever products you have, there's an EPD. And I mean, we're talking like shoes we wear could have an EPD. Then when we do a whole building LCA, we use the EPD for the windows, EPD for the brick, EPD for the insulation, for all the material components, and do a life cycle assessment of all of it. So that's the kind of composite, aggregated understanding of a whole building together. And with windows, what's been interesting is one way that we could have gone about understanding the emissions if an EPD for the system didn't exist. And I've done this. I've manually modeled the frame with the correct cross-sectional area of aluminum, and separately to that, I've gotten the volume of glass, and I've input aluminum extrusions as one side and then the glass as the other, and gotten to results. And I've had to sort of build the window EPD myself based on the raw material EPDs. Not necessarily the best practice either, but is one sort of way of going about it. So there's a million ways of like getting to the kind of end goal. And I think the highlight right now is that just gaining the understanding of how to do it is sort of still where we're at. The other side in terms of consistency and when a manufacturer brings someone in to develop an EPD, there's a level of consistency because it's a third-party organization coming in and doing that. And I don't know what the landscape is right now in North America. Europe, it's much more established. And in fact,
We have lots of certifiers.
lots of certifiers. And I think before a product comes to market, they have to have an EPD before it can even come to market. That's a regulation, at least in the UK. And you know, from my perspective, where I'm very caught up in like the question of consistency is when doing an LCA for the whole building becomes a requirement, how are we ensuring that what we're getting from one architecture firm is the same from another architecture firm? So it's the second layer of consistency and all that. So that's going to require a probably slightly bigger shift than, you know, as long as we have certifiers that can come in and start to do those quantifications for individual manufacturers, then we'll get at least the EPD level down. And then with one click, they have a whole branch that just does verification of those EPDs. So I think that side, it's more just about, you know, getting it
Well,
done.
And then we just have to figure out what the governments want to see. Right?
Yeah,
Like
yeah.
that's what's gonna ultimately.
That'll change what we're doing.
Is there anyone else before I keep going? Yeah,
Does reducing the body carbon have a effect on affordability?
So, I mean, you know, that's an interesting question too. If you speak to my business partner, he would say absolutely. You know, and I'm thinking we did a study at the firm that we had worked at before we started Half, and it was a retrofit of a building. And they had to bring it up to energy code. It was in Massachusetts, so a bit different to here. But to bring it up to energy code, they were requiring new windows, new insulation, new everything. And the cost was just outrageous. And so what we suggested was, instead of doing that, maybe we can just beef up the insulation, you know, restore some of the opaque envelope and keep the windows as they are. And it ended up, I don't want to throw numbers out because I'm not remembering the exact cost savings, but it was like we basically had to go to the ask for a variance on the building. It was adaptive reuse project. So there were lots of variances we were asking for, but you know, we had to, it wasn't going to be meeting energy code, but it was close enough and with a significant cost savings. And so we were allowed to move forward with just repairing the opaque wall. But that was, you know, it's quite anecdotal for now. It's very like project specific. We do the analysis and see what the outcomes are. Another example, the same firm, it was a old age home we were designing, and they wanted to put a bunch of levels below grade. And we said, well, there's all this surface parking already on the site. Why don't we just repurpose that? Saved like $500,000 or something. Like, it was a significant savings, not building down, and then also just repurposing the surface parking that was already there. So I would say you still need to do the math every time, but it often can be cheaper and contribute to more affordable options. When we start getting into some of the innovative materials like hemp and all that, there's a bit of investment because it's so new on the market and we're learning about them and all of that.
Hi, we're a small manufacturer of custom doors, and I missed the first part of your presentation. And my question is basically, are we heading for a new certification requirement we're needing here as far as materials go?
Quite possibly. I mean, again, from my perspective, it'll be a certification at the building level. So what I imagine will happen at a product level is developing what's called an environmental product declaration, a sort of passport of emissions that have gone into the production of the material. And that typically looks like bringing in an organization that knows how to quantify those emissions and getting that document produced, so that that document can live in these tools that I then use to do whole building life cycle assessments.
And the second part of the question would be, like, what time frame are we looking at here, if you had to take a guess?
Yeah, please.
So there's a lot of conversation at the National Building Code level about this. They're talking about having embodied carbon regulations in the 2030 National Building Code. So for us, 2032, 3, 4. So you need to start thinking about it now. Does anybody here, have they gone through the EPD process with their products? Curious if anybody's actually, can you speak to any of it, how it went, or consistency or accuracy, or what you had to provide?
Yeah, I can speak somewhat to that. So I'm from Corning Incorporated. We manufacture glass, and So we've gone through the process where we used a third party, company to come in and assess our manufacturing facilities. And then, like you mentioned, we are also using, and then they are using, I think UL is going to do our third party verification on the EPD, right? So it is a lengthy process. And I think we've been at it maybe 5 or 6 months. And I think the third party review process takes about 6 to 8, maybe 10 weeks to get that done. But it is definitely something that a lot of our potential customers have asked for with our new product. So it is going to be something that it will be required. And I would encourage everyone to really take steps now to get these going. They are lengthy, but to say that I think the data, right, that was gathered is certainly beneficial to other parts of your organization, and I think it will help a lot of people within your organization move forward with other projects. So, but there isn't really a lot I can speak to on the data side, but again, it is something that this industry will have to have and need quite soon. So, and we looked at getting them for both this North American market as well as other markets throughout the world. So that's kind of added to the level of complexity that we're working on, but something that we certainly felt was needed at this time.
Yeah, I mean,
So
great to hear that it's happening.
yeah. So think about your products, each piece and part, where it came from, getting a hold of that supplier, finding out what they're doing, where it came from, how it's made. It's a big deal.
Sure. So from a practical sense, a lot of this sounds like you're really just checking a box on an application or a certification program. The reality is when you go to sell a window, the homeowner wants to know what the payback is. And how does embodied carbon affect the payback of a window when you're trying to save energy and that sort of, how do you quantify that in layman's terms?
Well, I mean, I think the other piece to some of the data that we've presented is that we have no accounting for any kind of carbon tax or, carbon metric that could and should be associated with some of these results. I mean, again, I kind of would reiterate the comment about affordability. Every time we've done this assessment, we arrive at different results. And for things like the payback, I mean, we've been doing a lot of payback just with regards to operational and embodied. The cost piece, I mean, we had the one example for Victoria, the office building, where it made sense from a cost perspective. And it's sort of building and project specific to, I don't know. I mean, that's not a great answer for you, but to put it into layman's terms, because this is a very technical, kind of understanding, there's a layer of analysis that a typical homeowner won't necessarily even care about. But when we do start to bake in, I think very soon, some of the carbon understandings, and we're weighing that environmental impact more fairly, then we will probably skew to whatever the option is that balances both the embodied and the operational together, whether it's a triple glazed and maybe slightly more, or more money without considering carbon, or a double glazed with maybe a slightly less. And, again, geography is so important too. So, yeah, I mean.
So, just if I may, I'd like to just make a comment around it. Before I came into the window and door industry, I worked at Canadian Tire. My boss had come from Walmart, and we put together the LCAs for them. We didn't actually do it for a consumer perspective. This was in the mid 2000s, so it wasn't something consumers were really interested at that point. We did it because the corporation was looking to make business decisions. They wanted to understand because carbon ends up, the higher carbon you have, there's energy somebody paid money for. And as the cost was rising, they were concerned. They didn't start this. Walmart actually started this in the late 90s. And what they found was things that weigh less and have less material, have less carbon, but less energy and cost less. So it was for Walmart about driving out cost in their value chain. And so a lot of the retailers started to do that. And so this idea of embodied carbon came through the retail industry. So from a manufacturer's perspective, there's some great benefits of doing this if you want to think of it with an extra lens. If you say, hey, I want to look at my value chain to figure out where I can drive out cost. Can I change a profile? Can I do something to put additional number of windows on a pallet? Can I, do something to reduce weight? How can I look at pallets so that they are structurally just as sound, but weigh less or look different? As large manufacturers, this is a significant amount of money. And to the tune where both Walmart and Canadian Tire put this in their financial disclosure stuff. So it is something that we're looking at. You can do it as just check the box, but I'd say look for the opportunity to figure out how it might help you as well. That's
I think it's a great point. And kind of tagging on to that a little bit, less material, it means less heavy systems hanging off a facade, which means less structure. So it has ripple effects through the building where less material means less emissions, but also less cost. Same with transport, to your point. Pallets, you could get more on there. We account for transport from the perspective of emissions in an LCA as well. So if you're able to get more material with fewer trips, that's a good thing.
The geographic comment always comes back to me because I live just outside of Victoria. So putting a very high carbon product, triple glaze, big frames, etc., in Victoria, as opposed to maybe Winnipeg, makes no sense. Like, what's the offset when you talk about geographic location? And does it make sense from a carbon perspective to put these very high efficient products loaded with carbon into an area where their impact on the energy efficiency and the comfort of the home is much less than in a place like Winnipeg, where maybe that embodied carbon makes sense? So I've always looked at the geographic thing, and it needs to be addressed, and it needs to be considered through all of those discussions. It's like solar heat gain. Oh, did somebody say solar heat gain? Anybody else?
Have you looked at vacuum insulated glazing at all?
What is vacuum insulated?
VIG? Yeah.
Yeah, enlighten me.
I'm not the expert to be talking about it, but yeah, there you go. There you go.
So instead of a fill between your insulating glass unit, you make a vacuum in there. So there's nothing in it, right?
Yeah.
So it's theoretically the most insulating thing you can do. There's been massive attempts over the last couple of decades to get this right. And well, especially to be able to commercialize it, you need a very strong seal on the outside. You need to put tiny pins on the inside so the glass doesn't deflect and hit the other sides. But that's vacuum insulating glass. And I don't know, Terry, what are the U values they think they can get with that? Yeah, it's almost no, it's higher than that. Yeah. You can get about half of a wall performance out of glass.
Right. Well, I mean, there may or may not be an EPD that exists. I probably, maybe Windor 2024 will have a study that looks at all these different window systems and compares between them.
When I was looking at the different structures that you had up there and you wanted to go leaning towards mass timber, that also means that we have to have less dense cities because we're going to need 2 to 3 times more buildings than in the standard construction. What do we do about that? You can only go like 30 floors on mass timber with the hybrid.
Yeah, I mean, I think in Toronto, I would say maybe it's an allocation issue more than it is a density issue. I think that, you know, I grew up in France, so I'm a little biased to cities like Paris or London that are extremely dense and, you know, have a pretty big cap on how tall you can go. So I do think, you know, there's a few mass timber buildings going up kind of as I had to drive out here this morning right off the Gardner. And I'm all for more of that if it means that in the grand scheme of things, when we think of the, you know, carbon budget, that's a benefit from the perspective of carbon emissions. I also think there's benefits from the perspective of pedestrian life. More light is coming down to the sidewalk. You know, you're not getting the wind tunnels that you get when you've got really, really tall and then really, really flat. So I'm not opposed to a city where there's more spread out density to a shorter building. And also I think we can start to consider how much floor area per person we're comfortable with. You know, do we need to have X amount of space, or can we have a little less space and have more people in a building? I realize Toronto, that's funny because Toronto designs shoeboxes right now. I'm not saying smaller than that, but in the general kind of vein.
That was going to be my second question, is how are you going to get the customers on board? Because as sellers of product, we want to sell to the customers what the customers want.
I mean, I think that, you know, for me, just personally, we were just speaking before this talk about how even as an architect, my building science courses all told me put more XPS on the building, use triple glazed windows, right? That's the way forward. And then I got into my thesis semester and I met Kelly, and it was like a bit of a paradigm shift, learning that, oh, that's not the whole conversation, right? And this whole other piece has been sort of excluded from the equation. And I think that, gosh, I lost my train of thought there. What were we speaking about at the beginning? Yeah, no, I had it there. It'll come back to me.
The 250 square foot apartments now in Vancouver, they're popping up all over the place.
Yeah. Sorry, can you just reword your question again that you just asked? The second one?
Shout it out.
Oh, customers. Yes. This is right. So my point with going back to my schooling and having that paradigm shift is that I think that needs to happen a little bit with the customers. You know, I realize we look at Toronto, it's glass, it's steel. That's what the consumer wants, right? Views of the lake. And then you drive through Toronto and everyone has their screens pulled down because of privacy concerns, because it's too hot or it's too cold, you know, whatever it may be. So maybe sneakily through policy and research, we can start to understand that, you know, using these alternative materials, like going back to slightly more opaque walls, you know, very careful placement of windows, whatever that may be. I'm not saying those are the answers. I'm just saying that is the research that's being done. We can start to, and then those become requirements, right? So then designers have to build to a certain code. Then we start to form that paradigm shift, and the customers maybe will start to ask for these alternative things.
An important conversation that we all need to be thinking about, because like it or not, it's coming. So we're out of time. Juliette, thank you so much.
My pleasure.
Great presentation. And we're going to set up here in a few minutes for Jeff Makamoto and Silicones in commercial glazing.